Buenos días, mi nombre es Alejandro.
Good morning. I'm Alejandro Silva, and I work for GeneXus development team. I've been in this team for a long time, and I work in the generators division. So I'm going to tell you about what we are doing at the moment with regard to the new Angular generator, as well as other generators and the new technology we are using for this purpose. In this presentation, I would like to give you an idea of why these new generators are being built, what's in it for you in the short term, and what are the design criteria that we use in order to build these new generators, and what's the value for you. So in order to set the context, I would like to go back before the Angular generator and tell you about web applications and what we are doing at the moment so that you see where the Angular generator fits in. When you implement an application, a web application at the moment, you have to do two things. Firstly, concerning the server, you have to do the backend. And what goes in the browser is called the front end. What happens in the front end is the place what the application runs, where there is a user interface, there is a connector, etc. And at the back end, we have the services that serve the application that is running in the browser, especially what is concerns the business logic and also the database. What do we have in GeneXus for this purpose? How does GeneXus fit in this model? What we have in GeneXus right now is the following. When you use a generator for the web, you use Java or .NET or .NET Core, and this includes a web generator. There's no specific web generator at the moment, so you install a full stack generator for the front end and the back end. And for example, Java.NET, you have, for example, in the front end, a web code that is being generated. This is the case for Java, for .NET, for .NET Core. That is to say, all these three generators include a web generator. On the other hand, and it's here on the screen under front end, the web is a generator. On the one hand, we have the generator for smart devices, which I have included among the front-end generators because front-end smart devices is doing exactly the same thing for the front end. It shows the interface for the user that interacts with the services at the back end. It can also be disconnected, and if you generate an online application, you connect it to the server, and if it's offline, it stores the data locally, but eventually it connects to the service. There has to be another server behind. So it's another format of front end which is more sophisticated. Within this framework, I would like to introduce the Angular generator. What do we cover with all this? What other technologies we cover with what we have right now? In GeneXus, we want to be agnostic with regard to technology. We are not married to any of them. We try to develop the solutions that customers want to use, those that are more widely adopted, more consolidated. So we have quite a wide coverage of all important things that happen in the world of technology. We cover all of these databases and these clouds with our backend. And at the front end, we have in smart devices the two most important platforms. And for the web, we have our GeneXus generator that never had an official name, but we call it the GeneXus framework. It's a framework that we developed in order to build web applications. When you create an application for the web, it uses this framework. Same thing for .NET. Netcore, etc. Now, this development is very old. It started when internet started being. We've been making generators even before there was internet for the web pages firstly, then for Ajax. That's when we updated it. When the single pages applications appeared, we also modified the GeneXus framework together with the development of the web pages. And now we have the progressive web applications. So we went from web pages to a web app throughout the cycle of life of a website and web pages with our GeneXus framework. And why? Because there was never a technology with which we could say, well, this is consolidated. We were not able to say at any point we're going to stand on this because it's being widely used and the customers want it and it should be massified from the point of view of development. And this until recently. A few years ago, some sequences appeared. Angular, React, and Vue, which is a new one, appeared and have positioned themselves as an alternative that seems to be here to stay. They are being widely adopted in web developments. And at GeneXus, we decided that this was strong enough and good enough and was really making a contribution for us to think that it was going to be mainstreamed and continue for a long time, and therefore we should use them. So we decided to implement generators for all these libraries and frameworks. Nico spoke about this topic, so I'm going to go fast here. But I'll tell you anyway what these frameworks or libraries give us, what they contribute with. I could talk about differences, but there are many things they have in common. They all try to solve a problem, which is the speed of the render in the browser. They have a lot of differences and approaches, but they solve this problem very well. The technology called virtual DOM, which is that when you show an HTML page, it is uploaded in a DOM browser document. There is something that is showed. In today's applications, this DOM changes a lot. There are information pages in various places of the screen, and the DOM has not been thought to do this quickly. So what these frameworks did was the following. There is a virtual DOM, which is a copy of what they each handle or manage, and then there is a strategy to modify the actual DOM, which is running very quickly. So this is what is being solved, and they're good at it. They contribute with other things, and now I'm going to speak about the differences. Angular, for example, is a complete solution. If I want to make a web application, I just need Angular. I don't need anything else. Maybe I'll want to use other things, other libraries, but it would be enough to use Angular. That is why Angular is the one that is more widely used. It's a Google development, and it's been very successful in the corporate environment because it's backed by a very big company, and it's a solution that solves everything and creates no dependence on other things. It's very useful for everything that has to do with corporate. React is at the other extreme, and it's useful and attractive for front-end developers. Why? Well, it becomes obvious after you use it. If I want to develop a React application, I need a stack of solutions. With React alone, I can't make an application. For example, to surf, I need to upload a router, and I need to look for a solution to handle the status. So it solves the problem of componentization and update of the DOM, but I need a stack of other things, other libraries in order to work with React. Now, the front-end teams have been dealing with this issue for a long time. When we were programming with JavaScript for web applications, it was always necessary to integrate other things. So React feels familiar. It's a library that contributes with a lot of things. Anyway, it needs to continue improving its tool chain and its libraries, but it is very widely used to develop front ends, and it's very popular among front-end developers. And then Vue. Oh, I didn't say that React is a Facebook development. And Vue is the newest one. And it's more elegant in its solution. It's more or less like React in the sense that you have to add other things so that it will work well. But it's been growing very fast, especially pushed by the Asian market where it has been widely adopted. Now, we decided to create generators for these frameworks and libraries and started with the Angular one. And now I'll tell you how these generators look like, what we are doing. So I'll tell you about generators and generators technology at a basic level. And then I want to show you how the application works in Angular, especially insisting on the design criteria that we used for this generator, which add value for you. We used three pillars to create these generators. The first one is web components. Every time we make a generator, well, in the case of API library and GeneXus, there are some common features. Web components, as Nico explained very clearly, is a technology that allows us to extend the HTML. In HTML, we put an input and a button, but in this case, I can import things and tags, and these group elements and give me functionality. So it's like adding a level of abstraction with native elements that are run natively in the browser, because there have been specifications to see how it should work, and the browsers have adopted them. So I want to adopt components and componentize something, and I can do it in Angular and React, but it's much easier and much more useful to do it with this technology, web components. They are native and they run natively in the browser. What we did with the web components and the way in which we use the generators is that everything that has to do with GeneXus controls has been implemented in web components. This is an open project, and we made it with stencils. We have this tool chain called stencil.js, which has a compilator which allows us to produce these components based on a specification. The purpose is that they can be shared. Every time we build a new generator, we have to implement several things, which are always the same. We have a development pipeline which is clear, and all of the components have to be there. But we decided to do it in this manner because we want them to share them to share them with all the other generators. The other pillar is the API library, also known as standard functions. The previous generators, the oldest GeneXus generators, well, At the beginning, everything was functions. So in order to support these functions, you have to program a trim or the conversion of a date. All of these functions had to be implemented in the target language that we were generating, and this was called standard functions. Now it has other data, location, everything that is the API of GeneXus is implemented here. Another decision we took with this generation is to make it outside of the Angular so as to share it with other web generators that we create. We have also created it lightweight. The loading speed is very important, and one of the things we had to do was to concentrate on it being lightweight and easy to package with the applications and to package only what is being used. I'll show you later how it works. Another thing we did was to invert the process. When we release the CChat generator, we released later the standard classes, which are also public in a repository for those who want to see them and even modify them. But here we did it the other way around. The repository is public, and when a new generator, Angular, whatever, is released, it takes the classes from there. So it's a project that works by itself. This is what this library said. It has been developed, but there's more to do. And we take the input about how to establish these functions, these classes. We take it from GeneXus, and with that we create a skeleton that we complete with all the implementations. We also modify the development pipeline, which is very good because it will simplify afterwards the work of making other generators. And then finally the generator itself, which is the fundamental part in this work. We have a 30 years experience in making generators. They didn't exist when we started to develop this technology. We used Prolog, for example, which is an AI language that existed when we started, and it was very good and worked very well. But it has a very steep learning curve. In order to work with these generators, you need some experience. So with these new generators, we wanted to have an architecture such that it would use more updated techniques. We developed our stack of generators in Prolog, and 15, 20 years ago, we started doing more research about generators and others too. Some of the things were similar to what we are already done. Others were doing things in a different sense, in a different direction. So we said, let's have a generator as standard as possible according to the techniques that are being developed in this field. So we started almost from scratch. And I'm not going to give you many details because I'm probably going to bore you and it would take a long time. But just let me tell you that there is an SD panel in GeneXus that you make, and with this you create a metadata, as you see, with the description of what has to be done in order to generate the panel. The generator applies to this metadata a sequence of transformations. Each one has an intention, which is to get the metadata closer to the program to generate. And the last part in this chain is put into a template with a tool, and this creates the final code. So this is a technique to generate codes. And to give you an idea, the metadata is JSON, the transformations are in C#, and the engine we use is screen template, that is to say, as common as you can find. Now, this is the generator, and that was our design criteria to make something very standard. But what do we generate? Let's focus on the Angular generator. What we generate at the front end are these three layers, these three elements. On the one hand, we have the user interface, what the user sees. We have the UI element, the style and creates events that are afterwards programmed in a component. The word component is used for many things, but this is the code behind the user interface, this intermediate layer that has a behavior. When I push a button in the user interface, something that is in this behavior layer is executed, and it's the one that is in charge of keeping the status. This usually is done in JavaScript. And then there is a connector that is the representative of the server vis-a-vis the client. The simplest task is to get data from the server, and in more complex tasks, it can take data and send them to the server in a more sophisticated manner. So these are the applications for the front end. But how do we implement them in these new generators we are building? The user interface layer uses the components we have developed, and as I just said, and in code behind and behavior, we have the API, our library that has standard functions. Now, everything we have implemented so far, what we are doing here, this generator on the fly, I'm not talking about Angular here. Angular brings everything together so that Angular does what it does best. In this case, the updating of the DOM. So our idea was to use each thing in the best possible way so that it fulfills its tasks in the best possible manner. Angular for updating the DOM and the toolchain, and we don't implement the classes in Angular. We do them outside so that it can be shared with more generators. And also, we did not make the components in Angular so as to be able to share them with other components. So what I mean is that we have an Angular development which is quite advanced, and I will tell you in a minute what you can expect in the short term, how it will be made available. But we have already started to implement the React generator based on the fact that we already have the components and the API. So we can start the React generator using React for what it does, the update of the DOM very quickly. So we thought that this architecture would allow us to have faster generators, especially web generators. And this is what we are working on. And we want to start developing these two generators in parallel so as to test the way in which we are making developments to see whether we are doing it right. Now I want to show you an application. This event has an application, and you use it in Angular, in Android and in iOS, but we did it in Angular, so you can access it and play with it. So I'll show you a couple of things. And I want to tell you also about the design criteria in the applications that we generated. This is the meetings application generated with Angular. It is wider because it has been designed to function in a mobile device. And it adapted quite well. to this format. This is a grid. I'm here in one of the presentations, but it's not what I wanted. We have here another grid, and here we have today's keynotes. And I wanted to show you this page. Something interesting is how complex it is, and also the speed with which it works. This is a grid, this is another grid, another one, 3 grids, 4 grids, 5, 6. You can download this KB, it's public, this application, and the screen uses 5 components that, and so has everything is a component, and the performance is very good. This is one of the things I wanted to tell you about, not because I want to brag, but in order to tell you something very important. If I make an application in Angular or React or whatever, one would think that it's going to be fast. But this is not so. Angular, React, Vue give us the tools to make applications that work well and quickly. But you have to make them. It's not that just because you use them, they are going to be fast, and this is no small thing. This is one of the design criterion that we had to apply to these generators, that they were fast. So by showing you this, I want to show you what we had to do so that they worked fast. So this is the final version of the application, and this is in mobile. It worked very well. And how did we achieve it? Obviously, the first time we ran it, it didn't work like this. It was in red and yellow. These are the things we had to do, just to name a few. I'm not going to explain all of them, but an interesting aspect of this list that you see in order of importance of each element in the performance was that it's only here that Angular started helping us. The rest of the things were implementations that had to be made in React or anything that you develop. The lazy loading module, for example, when my application runs for the first time, I don't want to download it all. I want to download only when I want to see in that page. So we had to partition the application and package it so that they would work like that. On-site component refresh, this is easier to show than to explain. This is simple to show, but more difficult to make. If you look at these grids, you will be you will see that there are two and then one at the bottom. These grids are loaded when they appear. They are not loaded when the page is loaded. That is something we added to the components. They are loaded only when they are seen. Thus, it's very likely that the user will get into the first page and all of the grids are there, but they are not seen. So it goes to the user goes to the next page. Then the lazy loading image, the page lists that you can achieve with the GeneXus tree shakeable functions. This means eliminating dead code. And when I spoke today about the standard functions, the idea is that when we download the package with the application, I don't bring in all of the library, but only the functions I use. There may be 400, I use only 10. And it has to be done, it has to happen, it's not automatic. Then the mimification that we added to the generator itself, because it didn't mimify things that could be mimified at the beginning. And then the subproduct of all this work was that now we have Luciano Silveira in China, and there's WeChat and mini applications that are running WeChat and Alipay, etc. That's something new and it's good. They're becoming a platform, these applications in China. And Luciano said we should use the Angular generator to implement a generator for these applications. And Gaston yesterday showed you a video. He showed you what he did using these generators without a lot of background about generation, but they are up and running in this. So this is another subproduct of this generators technology. And to sum up, let me tell you about the scenarios of this Angular generator, what you can do in the short term when it will become available. I have to make a difference here between the applications we generate, and this is capricious. I'm going to divide them in two types. I'll call them the end user on the one hand and the back office on the other hand. End user would be eBay or Amazon, a web page where an inexpert user can do things like buying and putting things in the cart. They have a certain degree of complexity, but the most important thing is the performance. Whereas back office is used by experts who carry out complex tasks, and the performance is important, but the power is much more important. So between the two of them that can be made on the web, we have two generators that we have already released. The web generators that can make any of the two, and the smart devices which are more oriented to the end user applications, because we have two programming models for the web panels and the SD panels used by the smart devices generator. These models will be converted in the future, but right now they are based on the programming architecture of the smart devices. So the purpose is to solve the end user's applications. In this scenario, the applications that you will be able to do in Angular will be the following: to convert Android and or iOS to web app. That's what we did with the application for this meeting. The second scenario is that if you want to make a desktop app, for example, I have my page with my cart for the end user, I will add to the modeling of the panels the possibility of having a layout for these web panels where you will be able to generate an application according to the measure of the screen. And then we didn't think about this on purpose, but it's happening. There are some companies that have their development in Angular and use GeneXus at the back end, but are still doing some things because that's where they've come from. They are still doing them in React, for example, or in Angular. So given our architecture in 3 layers. The customer can eliminate one or the other and step in one of them in order to create something by hand. So you could work with Angular and then develop screens in React, for example, and use it on top of the services standing on the infrastructure provided by Angular. What is our roadmap with these generators? Firstly, in this event, we are launching a closed beta. We're going to select a batch of applications to work with Angular. We are looking for applications that are already in the store, and the purpose will be to convert them. Then we are going to have an open beta that we intend to launch in the first quarter of 2020, and the release will be by the fall 2020. React will come later, but not much later. And the Vue has not been planned yet. We are going to make it eventually, but we'll see how we are doing with the other two. So excuse me if I run long.